Welcome back to Chem Past paper. This is part 2 of IGCSE Chemistry, paper 4, variant 2, October-November 2023. Let's continue. This question is about lead 2 chloride. A student prepares a sample of insoluble lead 2 chloride by mixing aqueous solutions of 2 salts in a beaker. Identify 2 soluble salts suitable for making lead 2 chloride when mixed together. Now, this is a preparation of salt by precipitation. And in preparation of salt by precipitation, we use 2 soluble salts to form an insoluble salt, in this case, which is lead 2 chloride. Now, in order to know these 2 salts that were mixed together to form lead 2 chloride, we need to look at the product. Now, the product is lead 2 chloride. So that means there must be a soluble salt of lead and a soluble salt of chloride to form that lead 2 chloride. So the soluble salt of lead that can be used to form lead 2 chloride would be lead nitrate. And the reason why we chose lead nitrate is because nitrates are soluble in water. So don't choose lead sulfate, because lead sulfate is insoluble in water. So it cannot be used to form lead 2 chloride. So therefore, the salt would be lead nitrate. Then the second salt, that is a salt of chloride, would be sodium chloride, potassium chloride, or any other soluble chloride. So for this one, let's go with sodium chloride. So sodium chloride is soluble in water. So therefore, the 2 salts suitable for making lead 2 chloride when mixed together would be lead nitrate and sodium chloride. Next, write the ionic equation for the formation of lead 2 chloride by mixing aqueous solutions. Include state symbols. Now, in order to write this, I usually teach children to use the reverse method instead of using the long method. So how do you do that? First thing to do is to write your product, which is lead 2 chloride. And we already know that the lead 2 chloride is an insoluble salt. So therefore, it's going to be a solid. It's a precipitate. So it's a solid. Next is to draw our arrow. So that's why I call it the reverse method. You're writing it backward. Then we write the 2 ions that made up lead 2 chloride. We have our lead ion, and then we have the chloride ion. You write their charges. Lead 2 chloride, that means the oxidation state of lead is 2, so therefore the charge is going to be 2 plus. Chlorine is a member of group 7, so the oxidation state is 1, so therefore our chlorine will be negative. But from our formula here, we have 2 chlorine, so therefore we are going to add 2 here. Then when they are dissolved in water, they become aqueous. So therefore, we're going to write aqueous as their state because we are asked to include state symbols. So this is a simple way of writing the ionic equation for the formation of lead 2 chloride. Write the product first, and then you write the ions that are in the product. You write the ions that made up the product. You write the charges and also their state. Next, list the steps that students should take in preparing a pure sample of lead 2 chloride from the mixture in the beaker. Don't forget that it is a preparation of salt by precipitation. So in preparation of salt by precipitation, these are the steps involved. Number 1, you filter the precipitate. That's the first step. After you filter the precipitate, the next step is going to be wash the residue with distilled water. And then the last step is to dry it. Dry it between filter papers, or you dry it in a warm place in an oven. So these are the steps that are involved in preparation of salt by precipitation. The student carries out an electrolysis experiment on molten lead 2 chloride using the apparatus shown in figure 4.1. This is the apparatus. Chlorine gas forms at the anode and escapes from the apparatus. So this is it. Explain why lead 2 chloride needs to be molten before it will conduct electricity. So the answer is simple: so that the ions are mobile, or so that the ions are free. So you know that for an ionic compound to conduct electricity, it must be molten or dissolved in water. So, and the essence why it must be molten or dissolved in water is so that the ions will be free to move, or so that the ions will be mobile and conduct electricity. Next, write the ionic half equation for the reaction occurring at the anode. So at our anode, like stated here, chlorine gas forms at the anode. So that means we're going to write ionic equation for chlorine gas. And don't forget that at our anode, oxidation takes place. And oxidation is loss of electron. So therefore, our ionic half equation is going to be. So this is the ionic half equation occurring at the anode. So you should be able to learn how to write your ionic equation very well. Don't forget that at the cathode, reduction takes place, which is gain of electron. Then at the anode, oxidation takes place, which is loss of electron. Take the test for chlorine gas. So we use damp litmus paper to test for chlorine gas, and if the test is positive, the litmus paper will bleach or turns white. Next question, describe what is observed at the cathode. At our cathode, lead will be discharged because the ionic compound is lead-2 chloride. So therefore, what we will see when lead is formed at the cathode is shiny gray solid. Question 5. Chemical reactions can involve transfer of thermal energy. State the time used for the transfer of thermal energy during a reaction. So the time used for transfer of thermal energy during a reaction is enthalpy change. Next question. Tetrachloromethane gas reacts with steam as shown. This is the equation of the reaction. The reaction is reversible. The forward reaction is exothermic. So take note of this. State what happens, if anything, to the rate of the forward reaction if the concentration of tetrachloromethane gas is increased. Explain your answer in terms of collision theory. Very important also, you take note of that. So we're asked to write what happens to the rate of the forward reaction if the concentration of this is increased. So when the concentration of tetrachloromethane gas is increased, the rate of the forward reaction will increase and there will be more particles per unit volume, which will result to increase in collision frequency. Now you can see how I stated my answer, 3 points, because it's a 3-mark question. So don't just stop at the rate of the forward reaction increases and then you move on. You will lose a lot of marks because we are asked to talk about the collision theory. So you have to talk about collision, you have to talk about the rate of reaction, you have to also talk about the particles per unit volume. And also, do not make mistake of thinking that the equilibrium will shift to the left or to the right. No, that's not what the question is asking us. The question did not ask us what happened to the position of the equilibrium. The question is asking us what happened, if anything, to the rate of the forward reaction. So that is what should be your concern. And in that case, the rate of the forward reaction increases, there will be more particles per unit volume, and collision frequency increases. 3 points, 3 marks. Next question, state what happens to the position of equilibrium, if anything, when the pressure is increased. Explain your answer. Now you see this is the question that is asking us about position of equilibrium, not rate of reaction. So for position of equilibrium, when pressure is increased, we say that the equilibrium will shift to oppose that change in pressure. So how will it oppose that change? To oppose the change by shifting the equilibrium to the side with less gas molecules. So in order to know where this equilibrium will shift, we need to know the number of gas molecules on the reactant side, the number of gas molecules on the product side. The side with the least number of gas molecules, that is where the equilibrium will shift, because the equilibrium is trying to oppose the increase in pressure. So let's check our equation of the reaction. So this is our equation. The reactant, how many gas molecules do we have? We have 1 molecule of tetrachloromethane gas and 2 molecules of water. How do I know the coefficient? The coefficient is the number of molecules. So we have 1 here, and then we have 2 here. So 1 plus 2 is 3. So we have 3 molecules of gas. Then here we have 1 molecule of carbon dioxide and 4 molecules of hydrochloric acid, making it 5. So also don't forget that the reactant side is the left and this is right. So therefore, when we increase the pressure of this reaction, the equilibrium will shift to the left because there are less number of gas molecules. So the equilibrium will shift to oppose the change in pressure. So therefore, our answer will be equilibrium moves left because there are more gas molecules on the right. So you have to write the reason. It's a 2-mark question. So don't just stop at equilibrium moves left and that's all. You will lose a mark. You have to add because there are more gas molecules on the right. Next question. Figure 5.1 shows an incomplete reaction pathway diagram for the forward reaction. This is our forward reaction. So on figure 5.1, insert the formula of the reactant and product, draw an arrow labeled EA, which is activation energy, to show the activation energy. Okay. Draw an arrow labeled this to show the transfer of energy in the reaction. So this is reaction pathway diagram. So our reactant will be here and the product will be here. So let's write the reactant there. So this is how we place our reactant and our product. Next is to draw an arrow to indicate our activation energy. So this is our activation energy. Then finally, we have to show the enthalpy change. So this is our complete reaction pathway diagram for the forward reaction. Next, we find the term activation energy. So activation energy is the minimum energy that reacting particles, or you can say colliding particles, must have to react. That's a simple definition of activation energy. Next, step one way in which activation energy can be changed. One way in which activation energy can be changed is by adding a catalyst. Catalyst decreases the activation energy by creating an alternative pathway for the reaction to take place, thereby increasing the rate of reaction. Next, the equation for the reaction between tetrachloromethane gas and steam can be represented as shown. This is the display formula for the reaction. Table 5.1 shows bond energies. Use the bond energies in table 5.1 and the enthalpy change value for the reaction to calculate the hydrogen chlorine bond energy using following steps. So let's follow the steps. To calculate the energy needed to break the bonds in the reactant. So this is our reactant. To calculate the energy needed to break the bonds, we add the bond energy of all the bonds in the reactant. So let's start with tetrachloromethane. We have carbon chlorine bond 1, 2, 3, 4. So we have 4 carbon chlorine bond, and our carbon chlorine bond is 340. So this is going to be 340 multiplied by 4. Next is we have hydrogen oxygen. Now this hydrogen oxygen, how many they are? We have 1 hydrogen oxygen, another hydrogen oxygen 2, hydrogen oxygen 3, hydrogen oxygen 4. So it's also 4. And our hydrogen oxygen is 460. So it's going to be 460 multiplied by 4. So that's for the reactant. So this will now be equal to 3200. Next, calculate the energy released when the bonds in carbon dioxide is formed. So let's look at our carbon dioxide. This is our carbon dioxide. So our carbon dioxide, we have carbon and oxygen double bond, carbon and oxygen double bond 2 times. And our carbon and oxygen bond is 805. So therefore, the bond energy released when the bonds in carbon dioxide is formed is going to be 2 times 805, which will now be equal to 1610 kilojoule. So write our answer here. Next, calculate the hydrogen chlorine bond energy. Now, since we know the energy needed to break the bonds in the reactant, and we know that of carbon dioxide, we already know that our enthalpy change is the energy of the reactant minus the energy of the product. So that means to calculate our hydrogen chlorine bond energy will now therefore be 3200, which is energy needed to break the reactants, minus 1610 plus the hydrogen chlorine bond energy. So we check our equation of reaction. How many hydrogen chlorine bonds we have? We have 4 of it. Since we don't know our hydrogen chlorine bond, let's give it x. It's going to be 4 times x, which is 4x. Everything will now be equal to, look at here, we are already told that our enthalpy change is minus 130 kilojoule per mole. So everything here is going to be equal to minus 130. The reason why we did this is because our enthalpy change is equal to the total bond energy of the reactant minus total bond energy of the product. So what we'll do is to open this bracket using a minus. So this multiplied by this, minus multiplied by plus. So therefore, this is now going to become minus times plus is minus. So next is to collect like terms. And we show our minus 4x to be equal to minus 130. When this cross here, it changes to minus also. And then when this crosses to this side, changes to plus. So this will therefore be equal to, so to get our x, divide both sides by minus 4. Our x therefore be equal to 1720 divided by 4. Therefore, the hydrogen bond energy is equal to 430 kilojoule per mole. So this is how we solve it. Question 6, organic chemistry. So let's solve that. A homologous series is a family of organic compounds whose members have similar chemical properties. Give two characteristics that are the same for all members of a homologous series. So we have many characteristics of homologous series, so we are expected to write only two out of them. So they have the same general formula and also they have the same functional group. In terms of structure, state how one member of a homologous series differs from the next member of that homologous series. So they differ by CH2 unit, which means that if you draw the structure of the members, you see that they differ by CH2. For example, we have this is methane, this is ethane. If you see the difference is addition of one carbon from C1 to C2, addition of two hydrogen from H4 to H6. So that's why we say they differ by this unit. Next question. A, B, and C are organic compounds. A has the molecular formula C12H24. B has the name tetradecane. C has 3 carbon atoms and is in the homologous series with general formula CnH2n plus 1 COOH. Name the homologous series each organic compound belongs to. So the first one, we have C12H24. So how do we know the homologous series that this belongs to? We try to generate the general formula from the molecular formula. So this is going to be Cn. So our n is 12. So that means to be H, in order to get 24, that means we multiply 12 by 2. So that means it's going to be CnH2n. It cannot be CnH2n plus 2 because if you have CnH2n plus 2, it's going to give us 26, not 24. So therefore, this is an alkene because this is the general formula of alkene. Now next one, so it has the name tetradecane. So from the name decane, we already know that it belongs to the alkanes homologous series. And then this one is already showing the general formula for carboxylic acid. So therefore, the homologous series is carboxylic acid. So therefore, these are the homologous series each compound belongs to. Next, name C and draw its display formula. So let's look at C. Say that C has 3 carbon atoms. So since it's having 3 carbon atoms, that means it's going to be a propane. And since it's a carboxylic acid, that means it's going to be a propanoic acid. 3 carbon. 1 carbon is methane, 2 carbon ethane, 3 is propane. So, and since it's a carboxylic acid, the name will change to oic acid, so propanoic acid. So therefore, the name of compound C is propanoic acid. And we are asked to draw the displayed formula. So to draw the displayed formula, we have our propanoic acid, so it has 3 carbon atoms. So we draw the 3 carbon atoms first. And then it is a carboxylic acid. So we are going to draw the functional group, carboxylic acid. Next is to write the hydrogen bonding to the remaining carbon. So this is the display formula of propanoic acid. Don't forget that your carbon must have 4 bonds, not less, not more than 4 bonds. So if you check, all our carbons have 4 bonds. This carbon 1, 2, 3, 4. This one 1, 2, 3, 4. This one 1, 2, 3, 4. So this is the correct displayed formula for propanoic acid. Next question. Amino acids are a homologous series where each member has the general structure shown in figure 6.1. The R side chain contains carbon and hydrogen atoms only. That's this side. An amino acid has a relative molecular mass of 103. Deduce the formula of the R side chain in the amino acid. Show your working. So this is a simple question. So we already told that the relative molecular mass is 103. So we subtract all the relative atomic mass of all the atoms in the compound. So this is going to be minus. So let's start with nitrogen. The relative atomic mass of nitrogen is 14. And check your periodic table. This is nitrogen. This is nitrogen. You can see the relative atomic mass is 14. And minus, how many carbons do we have? We have 2 carbons. And the relative atomic mass of carbon is what? Check our periodic table. Carbon is 12. So it's going to be 2 times 12. Then minus hydrogen. How many hydrogen do we have? 1, 2, 3, 4. Relative atomic mass of hydrogen is 1. So therefore, it's going to be, the next one is oxygen. We have 2 oxygen. What is the relative atomic mass of oxygen? Oxygen is 16. So this is going to be equal to 29. But that is not what we're asked. We're asked to use the formula of R side chain. And this 29 is the relative molecular mass of R. So remember that our R, look at it here, our R side chain contains carbon and hydrogen atoms only. So that means the formula of R contains only carbon and hydrogen. So write our carbon and hydrogen. So now the question you ask yourself is, how many carbon and hydrogen will give us this 29? Remember that the relative atomic mass of carbon is 12. So if we have 2 carbon atoms, that means it's going to be 2 times 12, which is 24. Then if we do 24 minus 29, it's going to be 5. So that means our formula is going to be C2H5. This is the only formula that can give us that 29. Because if we do C3, that means it's going to be 3 times 12, and 3 times 12 is already 36. It's more than 29. If we do C, only one carbon, 12, carbon can only have a maximum of 4 hydrogen. So that means it's not possible. It's going to be CH4, and CH4 is not going to give us 29. CH4 is going to give us 16, which is not 29. So therefore, the formula of the R side is going to be C2H5. And the last question, state the name given to the natural polyamide formed from amino acid monomers. So the name is proteins. So protein is the name given to natural polyamide formed from amino acid monomers. That completes IGCSE Chemistry, Paper 4, Variant 2, October-November 2023, fully solved using the official mark scheme. Like, subscribe to Campus Papers, comment the next paper you want to solve. More full solutions are coming next. I will see you in the next one.